Hi there, welcome back. So let's address the other options that we have. So I will address only NDES, okay? QDES is the same. So these are for optimization, shape design, okay? So you want to know a little bit more the theory, what is happening there. You always look here. So for instance, see that NDES is doing of inverse design. No, this is full inverse design. And what we're going to do is to specify CP distribution, velocities, surface velocity distribution. Now we're going to say, okay, I want for this velocity surface distribution, what shape do I need? Okay, it's going to optimize or do the inverse design in that way. So kind of this is the method that is used, and probably to recall from the theory that you use on complex mapping, and that is stuff here, complex mapping. Enter. So I invite you to go here. You have two modes, MDES, which is the easiest one, the one I recommend to use, and then you have the other one, QDES, that is a little bit one that is going to give you a little bit more flexibility, but it's very difficult to control. Okay, so let's do this. Okay, so we load the airfoil. Okay, so we have it there with the finally and everything. So I will do something else. Okay, I will open, okay, to understand better, another window, the same airfoil, and open alpha 0. So one important thing that this optimization happens is done in V6 using the V6 solution. Okay, so we get that one. And also when you do this inverse design or optimization, usually you do it at cruise conditions, okay? Because every single different pressure distribution that you are going to have at different incidence angles, you're going to have different solutions, okay? So you know what will be your operating conditions or cruise condition for that one, for that specific one is the one that you're going to design. So this is your CP distribution that is related also to the surface velocity distribution, okay? So look at that, we enter here now, in this case, NDES, yes. And we have many options, okay? So see that it's doing some stuff here related to that complex mapping, okay? And we have all these options, but also see that it's plotting this. What you see here is this, exactly this plot, but now we split it in two parts. So here you have bottom, top surface, okay? So you always, when you're in doubt, compare with this one. So bottom surface, top surface, go from trailing edge, leading edge, trailing edge. Okay. So as you see here, this is, by the way, this is your surface velocity. Q, by the way, Q is not the dynamic pressure. Q here is the surface velocity, so it's normalized. So it's related to this one. CP also for in BC is 1 minus B over V infinite, that stuff. So you can get it from there, okay? So what we're going to do is to select a section of this distribution, and we're going to shape it according to what we want. And by doing this inverse design operation, we're going to get the new shape, okay? So as you look at here as the option, you have many options, and just to briefly explain you the options that we're going to use. So see that you have MODI, like geometry design. We use MODI to select some, insert new points, and then we're going to get a new shape, that's all. The modifications that we do here are global. So for instance, if I modify something here, this modification might also affect what is here. This is a big difference with the other QDesign. QDesign are local. So you modify here, it's only here. Here, you modify here, you might affect also what is happening here. So we're going to see that later. Then you have these options, smooth, just to smooth that we have this field. It's a filter, hiding filter. Sometimes when you do this inverse design, you can add in the surface, you can add some discontinuities there, or you can have some oscillations, and it's not a clean surface. So the handing is to smooth this one, to remove any oscillation, okay, or steps that you have there in your surface due to this inverse design. That can happen. By the way, also sometimes happen when you read in your airfoil coordinate, or the source from where you took those airfoil coordinates, might happen that you have some noise in your coordinates. Okay, it's not in a smooth coordinate. You have probably some stair-step behavior. So by using the filter, you can smooth a little bit the coordinates. It's not say that it works perfect, but it's a way. Just it sometimes can give you some improvement. So what we have here, okay, so what we're going to do is just modify and then exit to apply that. Okay, then you have some options to visualize, but let's say that modi. So look at, but it's important that you can also design by different angles. So by default, everything is done at 0 degrees or whatever you have in your buffer, okay, if I will recall. So see that you are reading this corresponds to 0 degrees. But let's say that you want to do some inverse design at 2 degrees. See that you have here AQ and you put 2 degrees and then you have the new one, okay? For our purposes, I will stay at 0 degrees. See that this is what we have. So we want to modify this. So see that we have modi, type modi, and then enter here and see that you have these options. So you can modify whatever you want, okay? So remember, bottom, top surface, and this is your leading edge, okay? So here, from here, you split everything. So let's say that I want to modify here and see that you insert the points. By the way, this one also you can give coordinate manually, there you can read in those coordinates. See that when you're happy, done, and see that now you have that purple line. See that whatever we're doing here, see that it's also affecting somehow this, okay? Instead, the other inverse design or optimization mode, it does not affect it here. Let's see that we basically change now the surface velocity distribution to have this shape. And now we're going to do the inverse design to get this shape. So to do that inverse design, so now that you have that, you have exit. And see that it's going to do it, and see that also precisely it's not going to get what you're proposing, but it's trying its best. And see that it's doing this, and see that now you have your new coefficients, okay? So see, we have the other one, CL, CN, see that we can compare. So see that this wasn't very good for CN, okay, I increased it a lot, but see that you're modifying there, and this is your new shape, okay? So remember that you have buffer, airfoils, and that stuff. So still, this is, you are here, no? We still, you don't have this airfoil in your buffer to be ready to use, okay? You are just doing this stuff. So you can run different iterations now. So you can do another modi, okay, and for instance you didn't like this and you apply, so probably this is not very good. So see that you apply that exit and see that you have it there, okay? So you can run as you see, you have to be very careful, and you can also apply this filtering. So let me go here, so one filter, two filters, okay, and go back modi. Okay, so the filter is just trying to filter that, just to, okay, done, to remove any oscillations. Here we don't see it, but you can apply several of those filters, and if you have any fluctuation there, it's going to this. Be smooth. So see that, okay, let me stop there. That, let's say that I'm happy with this, okay? This is your airfoil, okay? And as you go to, let's say P part, look at that, still that airfoil, you don't have it here. So you modify that in NDES, but then you need to make it available. To make it available, you go in GDES and see that in GDES you have that airfoil, okay? Kind of that. And this is recalling this one, and as you recall from the previous videos, that here we need to do the pass. Now we need to go to exit, or as you have GSEC to go back to the original one. So if you are happy with this one, exit, and see that now you have your airfoil in your buffer, and to be sure, P-part, see that, and this is what you modify, okay? And now if you go into Upper, voila, your airfoil design. So this is the original one, And after that inverse design or optimization iteration, you have this. Again, as you see, it's difficult to control, okay? So this stuff is better to do it using parametrical methods, optimization methods. You put it in a loop and it's better to control, but you can do it manually. So you're happy with, okay, by the way, you can also run in viscous mode, okay? So all this inverse design is doing in viscous, then you run the viscous modes, and obviously you're going to get, there are some differences, but see that, nice. I'll see that by adding now the viscous, you have a nice effect, okay? And this is what we have. So, for instance, you can go back in this and apply another optimization there. So let's say AQ, let me run it, let's say I want to run at 2 degrees. So see that now it's changing my condition. So everything, it will run that case to get this distribution, the other line, at 2 degrees, and then you will do modi. And probably here you can add your points. Also, okay, done. Okay, let me, you have an option there here called blow. That is a zoom. Let me zoom from here. Modi, and let me say that I want here, 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 and here. Okay, so probably this will be much better. Voila, this is much better. See that now I'm smoothing that. Okay, and I go exit to apply that, and see that have here always in basic solution. Okay, so on previous one, what we see previously, it was a 0 degree, by the way, and see that you have an effect there. Okay, so let's say that I'm happy with this. This exit. It's this exit and upper alpha 2, and now an alpha 2. Okay, this is our case, and see that you have the basic solution, and see that we smooth it a little bit. So see that you have this noise here. Okay, that is third step behavior. That can happen. Okay, so you shouldn't be worried about that if it's small. Okay, if it is large, okay, something that you should be careful. But what is happening here is that when you are modifying the geometry, you are modifying the whole stuff, in this inverse design. So it might happen that here there are some small oscillation, fluctuation that add that. That is the panel, okay? You have panels that you have some strange orientation between panels, and you have that, okay? So you can smooth that, as I say, using that Hanning filtering, but sometimes it doesn't always, not guarantee that it will always work. And to point out also, it is important that this might happen when you are importing airfoils for external files. Okay, so you can apply that filter to try to mitigate that. So this is how this inverse mapping works. Okay, so I want to show you actually that I'm talking about that it might happen when you import some external airfoil. So let me show that. I think I have one airfoil that happens. Okay, so I will load an airfoil. My airfoil is that, if I would recall, that was the right name. Okay, now it's -1. Okay, we have it, and look at this is the airfoil. If you recall from the lectures, this is the airfoil that corresponds to the Honda jet. So see that, if you look at here, you see that it's not perfect. Okay, so see that the panels, you have this orientation that changes the angle. It should be something smooth, and visually you can share, you can see those oscillations, or that is third step behavior, and that will influence your solution. Just to show you, if I go upper and visit alpha 0, see that you have all this behavior. That is those panels that they are not oriented now. You have problems with the orientation, and this case that is something that might be problematic. So we go p-par, probably I can increase the panel in to 300. Okay, And see here, even see here that what is XFOIL proposed, and see that is putting a lot of panels here because it see that there is a change in curvature. So maybe this is a case that you can control this manually to avoid this clustering. Okay, so well, in any case, let me go here and run now with more panels and see that didn't help much. So a way to try to mitigate that, in this case, is not going to solve. No, it's better to just to use an external software and apply some filtering directly into your input data. See that you have all this noise. So this we need to filter. So we can use this hand-in filtering. So if I go here, fill. Okay, see that it's smoothing a little bit. Apply another. See that this smoothing there. Okay, probably let me zoom in to visualize that better. Up, it's blow. Strange name for a zoom, but okay. So fill. See that. Smoothing, and let's say that I'm happy, exit, and see that after all those filtering operations, see that I have this smooth behavior. Now I'm happy, GDS, exit, open, alpha 0, and see that now I smooth it. Okay, so in this case we had to apply a lot of filters. Okay. So see that it worked, but that is not good. That means that your original data, you have problems, so it might be better to check those coordinates, to shift a little bit more those panels to have everything perfectly aligned. But by using that filtering, we managed to get something, let's say, good. Viscous mode, and let me run here 0, and ether 100. And alpha 0. So see that this case is having problems. Okay, even if we smooth it at the level of the basic solution, the viscous one is having. So let me go in it, alpha 0. Might be the problem there. Okay, yes. Not good. So let me go alpha 2, sometimes larger. So probably alpha 2, yeah, is much better. Okay. So see, alpha 2 is better. So you have one noise, we managed to mitigate it, but the invisive is clean, but we have problems there. Okay. So, well, we talk about, I think we cover a lot of stuff. I'm not going to talk about QDES. QDES is kind of very similar to what we have done, but in QDES, now whatever you choose to modify one section of this surface velocity, and you just apply that modification here. Okay, so you will have some other options that you need to mark the region where you want. Let me go here. You need to mark the region, so you mark a region and then it will modify that region, but this is a little bit more difficult to control than the other one. Okay, because you modify only here, but sometimes those modifications are too large. Okay, instead in the other one you do a modification and it's all propagated all around to have continuity in the curvature of the shape. Here there is no warranty on that. So that's all. Also we study important how to try to remove that noise in the coordinate. So I think we covered most of the important things. There are some things that I didn't cover, but just explore that. Okay, it's on additional options, but we covered the most important stuff. Very important, read this short documentation. Well, not so short, but it's a very nice documentation. You can get more information there. And I think that's all. Okay, so the next video I'm just going to show you how to plot the data using external application. We're going to use Python, but you can use whatever you want. What is important is that you need to have this information. Okay, so see that in my case that you have the link, you can download this data, see that you have these outputs, so you can plot this one. So I'm going to show you how to do it using Python. So that's all. Thank you very much for your attention. See you in next videos. Bye.